data analytics in medicine is to provide panoramic views of medical data to improve decision making. Prayer isn't asking, it is a longing of the soul. I request Harini to begin this program with a prayer song.
Mahaganapatim manasa arame Mahaganapatim manasa smarami Vasishtavama Devadivantita Mahaganapatim Mahadevasutam Guru Guhanutam Mahadevasutam Guru Guhanutam Marakoti Akasham Shantam Mahakavyanatakaati Priyam Mushika Vahana Modaka Priyam Mahaganapatim.
Thank you, Harini. Small cheer and great welcome gives a tremendous joy. Here comes words of welcome to everyone from our beloved HOD ma'am, Dr. T. Sheila, Department of Information Technology and Networking Dean. Please, ma'am.
Thank you. Good morning, all present here. First of all, I would like to welcome Dr. Ranira, Doreen, data scientist, keynote speaker. That is a machine learning and digital learning trainer, the director, CIRF and administrator. This is the program for industry-sponsored program. It's Computational Intelligence and Research Foundation, CIRF. Thank you, madam. Thanks for accepting our invitations for the 3 days program. It's totally hands-on training session. So we want to conduct in physical mode, but unfortunately, so we are conducting in virtual mode. Next time, we will try to implement for our students that hands-on training in a physical mode. This is the 3 days industry-sponsored program is on predictive healthcare data analytics. So that I hope that all the members in this group will utilize this opportunity and learn something from this 3 days FDP faculty development program. Thanks to the organizers, Dr. Arlene, Sharada and Saranya for conducting this program for our faculty members. I welcome all the staff members and also the other participants from various institutions. I hope that the other members will join shortly. Once again, I have welcomed Dr.Doreen for this today's function. Thank you. Thank you. Thank you.
Thank you, ma'am. Predicting the future isn't magic. It's a real experiment for data analytics. With immense pleasure, I now invite Dr.Doreen, data scientist, keynote speaker, machine learning deep learning trainer, director at Computational Intelligence Research Foundation, administrator at Bethel Matriculation and High Secondary School. Thank you, ma'am, for accepting our invitation. We welcome you, ma'am. I kindly request you to take over the segment.
Thank you, Aarti. On behalf of Computational Intelligence Research Foundation, I wholeheartedly thank SAIRAM group of institutions, especially the Department of IT of SAIRAM Engineering College, for having invited me for this 3 days virtual hands-on session, or you call it as industry-sponsored project on predictive healthcare analytics. Hope you are able to hear my voice. Can I see your reactions like thumbs up? If you are able to hear my voice? Yes?
Yes, ma'am.
Yes, thank you. So it's a pleasure to be with you all today. And I was seeing the vision of this workshop being conducted for the faculties, for the research scholars, and for students. And I hope there are multiple participants who have registered. And I could say the way that you come in will not be the way that you go out of this session after 3 days. There will be a learning session and where you're going to experience it. As rightly said,
recording in progress
by the HOD of IT department, Dr. Sheila ma'am. Yes, it is going to be a hands-on session. and sometimes you wonder it's online, how are you going to have it? Is I will be sharing my screen with you, and you also will be parallelly working with that, right? You need not install any of the softwares. Only if you've got a system that is connected with the internet, the answer is yes, because you're all into the Zoom, all right, and it's a virtual workshop, and you'll be truly experiencing it. Okay, before I start, this will be an interactive session. I want you all to interact, and we'll be having quizzes, some works to be done, and you will be presenting it to you. So the 3 days I've scheduled in such a way that it is accordingly. There will be a learning session, like a blended learning session, all right? And before we start, okay, I'm going to ask you all a simple question. You can put your answers on chat. How are you today? Right? How are you today? I want the answers to be quick. The more quick, the more we'll be able to learn. I know some of you are even more brilliant. You know more than me. It is like a learning. I learn from you and you learn from me. Thank you, Durga Devi ma'am. It's good. You can give one word answer. How are you today? Just one word on the chat, quick. Like we have like 33 participants right now. Fine. Okay, thank you, Menaka ma'am. Others? This is the only way, because it's virtual, right? This is the only way we could find how many of you are really connected and how are you responding. Just one word is enough. How are you today? Can you quickly give their answers on chat, please? Yes, what about others? Only 2 of them have responded. Kindly be quick. I want everybody to give just one word answer. How are you today? Quick, please. Thank you. Renny Joe's fine. Others fine. Thank you, ma'am. I want everybody to give just one word answer. How are you today? Yes, others, please. Kindly, let's be quick. Fine. Yeah. Fine with the same, ma'am. Thank you, Dr. Muthuselvan, sir. And others. Let's be quick. One word. I need not even need the word, ma'am. How are you today? Just fine. Good. Yes. Thank you. I'm fine. Thank you, Sevi. Thank you. Energetic. Thank you, Harini. Energetic. See, I just asked one question. I want everybody to answer quick, please. I hope everybody have got the access to chat. Quickly put it onto the chat. How are you today? All right. See, this is a simple question, right? The simple question I asked. And can you see what are the different kinds of answers? Good, energetic, fine. Okay. These are 2, and many of them have used fine. Okay. So these are different words. The question is the same, but the answer response is also is a positive note, but the words are different. Data analytics, data analytics is a subject where you're going to more predominantly analyze with huge volume of data and draw insights from it. So how many of you have worked in healthcare analytics or predictive analytics or predictive modeling? Or to make the question very short, how many of you have used or you have been working in machine learning algorithms? If you have been working, type yes. If you have not been working, if it is new to you, type N. I want everybody to answer. I hope you are all able to hear me. Yes. Have you been working in machine learning algorithms, hands-on using Python or different languages? Type Y. If not, type N. No? Okay. So I'll be able to understand the end audience. Okay. Thank you all for your responses. So let's start with the session. Listen carefully to the session. We'll be having the first session between 10 to 12. And you have a break between 12 to 1. And the next session will be in 1 to 3 for the 3 days, right? For 3 days. Now, are able to see in my
Yes, ma'am, your screen is visible, ma'am.
Yeah, thank you, Aarti. Okay, so we'll have a blended of a theory session and also a little theory and more on hands-on session, right? So this is the 3 days program. One day, once again, I would like to thank the entire management for organizing it. See, we are going to see on 3 days about the predictive healthcare analytics, all right? Okay. And here we'll be taking a data of first day today. We'll be trying to take a data of a kidney disease and how are you going to visualize it, and we'll be developing machine learning algorithms eventually tomorrow. And the following day we also will be taking up image data sets and how are you going to load your image data set, from which how are you going to segment or how are you going to find the disease that is present on any images. It could be an MRI, whatever is the image data sets that you're going to take. All right. And first, we are going to see about how are you going to classify. When you take a disease, right, what would be the output of diseases? If, say, for example, if you want to find a person is diabetic, what would be the output? You can also feel free to unmute and answer. If we want to find a person has got diabetic, what would be the answer for this question? Yes, please. I hope you're able to see in my screen and you're able to hear me. Yes?
Yes, ma'am, you're audible.
Yeah. What would be the output if I want to know the person is diabetic? The answer will be either yes or no. Am I right? Yes or no. So I'm going to classify, right? I'm going to classification as one module that we'll be seeing in predictive healthcare analytics, whether a particular person has got these disease or not. All right, that disease or not. So healthcare is one of the most important domain for predictive analytics. We'll be going to start from the basics of analytics, but when you focus more on the healthcare, okay, there are many applications that they use predictive analytics. For example, the sales. If you are going to have a business, how far your sales? If your sales of January month is like that, February is it going to increase because of some offers or patterns that you give, or it is going to, if it is decreased, how far you're going to increase your patterns, and then keep forwarding. When you take your most of your faculty members, all right, and you have got a very good predictive system. A student comes to your campus first year, you don't know anything about him. After a few months, you know, before he goes to the he approaches the exam, you know, these students will pass and these students may fail. That is what you try to learn, patterns from the data. Right? Patterns from humans, that is what is the examination. Then you say you will pass. If you find the students may fail, then you can take some special classes or something or the other. So predictive analytics is predominantly spread out in various applications, and it's very successful. And when you come into healthcare analytics, is most popular analytics, like many of the researchers are PhD scholars or research organizations are working onto it. Lot of competitions are coming. Once you know about this, you have got a resourceful pool of students with you. Once you are trained through you can train your students and you can go in for competitions. And I tell to faculty, see, one unique thing, as they said, I was being a professor and HOD for a decade of teaching, and then I started this company called Computational Intelligence Research Foundation. As a Section 8 company where we work on research and development on various domains. One such domain is machine learning, deep learning, cyber forensics, cyber security, software testing, knowledge management, and so much and so on. And also we provide internship to students. Okay, well, some students, they stay in a company for 6 months, they learn, they develop project, they write journal papers. If it is really unique, then we go on for patent. All right. One unique thing about CIRF, I could say, we also provide faculty internships. Everything is hands-on. Why? Because some of you would have not learned about what is there in the syllabus. I personally feel, and in my company we feel, internship for faculties is also much needed. A set of faculties from different colleges have come to my company. They've stayed for 5 days from morning till evening, hands-on. At the end of it, they develop projects and they go, and they say it's very useful because we are hands-on. These 5 days gives them the energy to share the knowledge with the students, and students are so smart, more than us. All right. What does predictive model generally does in any application? It uses the historical data. You learn from the data. Learning the data patterns is mostly what is called as analytics, right? Learning the patterns from the data, finds the patterns and generate accurate predictions from it. And it generates accurate predictions from it. All right. So when you take a predictive model, say for example, you are all faculty members, most of you, right? And sometimes you have been a student. So when a faculty is coming to a class and taking class to you, you have your internal exams, then you know how far these students they behave and how they respond in class, and when you ask a question, how they behave themselves, how are the answers towards you, are they accepting what you are going to say, are they repelling, so many things. You get the data from the students and you learn from the students. I'm going to ask you a question. As a faculty, you have got 40 students in your class, right? Are you going to approach all the 40 students in the same pattern, or each student you change the pattern in how you approach to the students? When you call and talk to them about the academics or something about their lifestyle or something, are you going to use the same pattern of language to all the students, or you vary the pattern how you speak to different students in your class? You can also unmute your mics and speak, please. Hello? Or you can put your answers on the chat. Yes, please. Hello? What is the pattern? I repeat the question. You've got set of students. All right. You call the students, or you're going to speak to all the students in the same language, or you're going to change the pattern and according to how the students accepts it. If you find a discipline issue or in the academics. There are 34 faculties here. I want anybody to unmute and speak, please. Yes, please. Hello. Yes, even the students, if you're here, you also could answer. Is the same way a faculty approaches towards you, or the approach is different? You want to have a one-way session, or we want to have a two-way communication? I generally prefer an interactive learning session. Yes, please. Anyone? Or you can give your answers on chat. Every faculty has a unique way of approaching. Thank you, Aarti. It is not the same. It is not the same. Every faculty has a unique way of approaching every student according to the language they accept. Some students, you say, kindly do this. No? For some students, if it is no, what you're doing is wrong. So we, as a faculty, we learn the patterns from the students, and accordingly we approach it. So what is data analytics? In short, it is learning patterns from the data, learning your data patterns, learning, if you're making a notes of it, kindly make a note of it, learning the data patterns. Okay, how far the patterns are there, right? That is, in short, is called analytics. So when you come into predictive analytics, you find very correlations. How far these, like a professor, like one of the professor has given, when I asked for, yes, the Nakaran sir has given, when you want to find what would be the output of a person has got diabetics, it's yes or no was the answer I expected. But see, he has given a very specific answer based on the blood sugar level. Listen carefully, based on the blood sugar level, wherein you try to understand, when you want to find, can you find there's a huge correlation between the blood sugar level and the target whether the person has got diabetes or not. Okay, I'm going to give you one. This is one feature. Okay, blood sugar level is one feature from which you are going to try to find whether the particular person has got. It has got a strong correlation. Do you admit it? The blood sugar level has got a strong correlation towards my target, wherein I'm going to find the particular person is going to have a diabetic disease or not. Yes. And now I'm going to give you another features. Okay, taking into the diabetics, what are the features that you think that are needed? What are the columns that are needed, or what are the features that is needed to find whether the particular person has got diabetic or not? I kindly encourage everyone to give your answers on chat. Otherwise, I need to understand that you have switched it on the workshop and you are not connected. Hello? What are the features? Okay, I'll give you an example. Whether age of a particular person has got a strong correlation towards the target or less correlated. Strong means type S. If it is less correlated, type L. Just one letter is also enough for me. But I want you to give an answer. Yes, please. Less correlated. Thank you, Karthikeyan sir. What about others? Feel free to answer. Feel free. Okay. Then, what about others? Only one answer? I want everybody to answer, please. Okay. Please answer. Yeah. Rupa. Okay. It's a good question. My question is, the age of a person, see, we were speaking about the blood sugar level of a person has got a strong correlation towards my target, whether the particular person is going to have diabetes or not. That's one feature. Blood sugar level is one feature. I'm asking the second question. The age of a person, just an age of a person, has got a strong correlation towards the target, or it is less correlated towards the target. What is my target? The particular person is diabetes or not. Strong means type S, L means less correlated means type L. The age, like Karthikeyan sir said, rightly said, the age has got less correlation towards my target, whether the particular person has got diabetes or not, whereas blood sugar level has got a high correlation towards my target, because when the value of the blood sugar level is high, it clearly demarcates that particular person is a diabetes patient. All right. And it also finds various correlation. You can, in one function, you can find the correlation between different features towards your target. And association of symptoms. Okay, what are the symptoms generally we see for COVID? I have experienced COVID. Some of you would have experienced. Some of you would have not experienced. But I know everybody, you know, what are the symptoms of COVID? Can one of you unmute and speak, please? Hello.
Yeah, good morning, ma'am.
Good morning, sir. What are the symptoms of?
Actually, COVID produced a breathing problem, ma'am.
Yes.
Then I had a breathing problem. I'm not able to breathe. So it affects the air tracheas.
Okay. So that's one symptoms. What are the other symptoms?
Then it gives chest pain.
Chest pain. You get cold.
Because breathing problem, suppose breathing problem exists, means definitely chest pain will reduce now.
Yeah.
So chest pain, then tiredness.
Cold.
Finally, the conscious level is reduced, ma'am.
Yeah, the oxygen level decreases. Then you got cold, you got fever. Yes, you had breathing problem. See, when these are
oxygen level, intaking oxygen level is reduces. So the air trachea have a high resistance. So when oxygen is not able to go to the lungs, once the oxygen percentage of oxygen is reduces, means definitely the oxygen is very important. It the brain cells need oxygen, the neurons. So less amount of action means neurons gets tired, and the neurons, what happened? They produce a damage in the neuron also now.
Yeah.
Because action is the food of neuron.
Okay. Thank you so much, sir. Thank you for your active participation. Yeah. Yes, and again, Richard Hadley sir has given coughing, sneezing, head care, headache, cold, fever. So these are some diseases, some symptoms we think we are associated with it. So the symptoms, when it is on, or if the symptom is present, these are symptoms that have gotten high correlation and association towards the disease that you would like to predict. So focus on to the topic that we're going to see. Pujita has raised hands. If you've got question, put it onto the chat, or sometimes or the other, you can also unmute and speak. You find the habits, diseases, and make meaningful prediction whether the particular person is going to have a disease or not. So coming into predictive analytics, it plays a very important role to find the patient care. Okay, how far the patient is going to survive, or the patient is going to die, what is the medical facilities that you need to give. See, in medical field, there's a huge innovation that is going around with the background of analytics. John Hopkins University, the hospital, has produced, they've taken a CT scan and they've used your AR glasses, and the CT scan image has been embossed onto the patient, and they've done a surgery for a 70-year-old woman who has a spinal cord pain. She had a tumor in it, and they were able to extract exactly with the technology, and now she's fine. Maybe sometimes I've shared that video on my YouTube channel. When you're free, you could also see to it. All right, if I find time, I will share it with you. Okay, so this predictive analytics, it improves the patient care, chronic disease management, it increases your supply chain. We were all hunting for what? For during the COVID, every person were hunting for the supply of, yes please, supply of efficient oxygen. Yeah, we were trying for oxygen. Once we are sick, we were also trying to find beds in hospital, right? How many of you had the struggle, or your relatives had a struggle? Yes, beds, rightly said. Beds, we were not able to find hospitals which has bed. It's not what hospital just to have a bed, to have an oxygen. All right, so you can predict it. Okay, now you can predict the energy efficiency of supply chains and pharmaceuticals logistics, whether particular medicine is available or not. So predictive analytics plays a very important role in healthcare, right from the patient to the paramedical, to the availabilities of bed, to the availabilities of doctors. All right, see, this population health management is becoming very quick. Every second, people are born and people are passing away. Okay, and when you come into predictive healthcare analysis, it's a data-driven approach focusing on prevention of disease. Okay, so what is the prevalent disease that we know here? Now it is COVID. For the past 2 years, we have been juggling around with COVID, right? And with data sciences, hospitals can predict the deterioration in patient's health. Say, for example, okay, if you for an emergency, if you go to an hospital, okay, and say for example somebody has got a chronic heart disease, okay, you go into a government hospital or any hospital, and you don't know, you are into a new place and you don't know about the hospital, but you have given a choice of 5 doctors available, cardiologists available. Okay, how will you, suppose if you have given a choice, you choose one of the doctor who wants to treat because it's an emergency, what will you do? We don't know about anything. Say, for example, if you go and you have a bigger display, this is Dr. 1, Dr. 2, Dr. 3, Dr. 4, Dr. 5. These doctors, you see in analytics, this doctor has treated so many patients, 1,000 patients, and out of which 800 survived and 200 passed away for the past 5 years. And the next doctor, for the same 5 years, he has been treating 500 patients, and like 450 survived, only 50 passed away. Like if you have got an analytics of this, okay, whether it will be an easy task for you to choose the doctor, yes or no? Answers on chat, please. Yes or no? Okay, visualization and analytics plays a vital role. Visualization And analytics plays a vital role. So it's not only knowing analytics, how are you going to apply it and where? Do we have any hospitals right now? When you go into a hospital, do you have a visualization chart? How many patients that hospital has treated? How many patients has survived? How many patients has passed away? Will it not give you a good chance of choosing an hospital for treatment? Yes. Yes. So we don't have, these are some ventures where you can think of working on with that, right? So furthermore, predictive analytics plays in monitoring the logistic supply of hospitals and paramedical. We have research scholars worked under me where we have like patient scheduling. Say, for example, a doctor A goes to hospital 1, hospital 2, hospital 3, hospital 4, hospital 5, and he can have an application of scheduling it. All right, and whether if he is not available, an immediate message could be sent to him. Okay, you know about IIT Mandi, right? IIT Mandi. Okay, they have developed an artificial intelligence based monitoring applications for COVID-19 patients, because when suppose some of you have experienced it, when we get COVID-19, people don't come near to us, or we are isolated or something or the other, right? So the IIT Mandi has developed an AI based monitoring applications for COVID-19. In addition, it also serves as an unreachable mobile phone platform for normal mobile users situation under, so that anybody and be able to find out how the patient is available. Sometimes you send the patient to the hospital, they are isolated and you are not able to find out to them. All right. So when now we are going to focus on healthcare, what are the different, because you are researchers and you are scholars, where and all you can start working on with genetics and genomics. How are you going to use the data management? Like Tamil Nadu, they're widely having a good data management system, right? And you can just call to the number and they were able to say whether the hospital beds are available or not. And we had virtual assistants. How anybody here experienced, you were not able to go to the doctor, but through the video call, whether you have got any treatment, anybody attending this webinar today or the workshop today? Yes. Type Y on the chat, no, type N on the chat. Yes, thank you, Adeline ma'am. Okay, we had got virtual assistants. Even doctors were feeling so afraid to see the patients, right? What about others? Others never got any virtual assistants? Yes. Yes, thank you, Karthikeyan sir. What about others? Only 2 of them are responding. We have 44 people. I want everybody to respond. This is one unique method for the organizers to know whether you're really connected to the session or not. Okay, the drug discovery. What are the 2 vaccinations? Covaxin and Covishield. Right, Covishield, you know, there's a lot of AI had been running at the back to find the patterns of it for the vaccination. Predictive analytics, that's what you're going to see, and also we'll be seeing about image analytics by today and tomorrow. Okay, today and tomorrow. So data science, they play a vital role. They provide virtual assistant, data science and genomics, drug discovery, and one such part is predictive analytics in healthcare. That is what we are going to predominantly focus. What we are going to focus? Predictive analytics in healthcare. Okay, so providers who use advanced predictive models are tackling the following clinical challenges. 27% are predicting readmissions. Okay, 18% are predicting the patient's deterioration, 27% are predicting sepsis, and 10% are predicting general patient health, and 18% are finalizing their decisions. Okay, so what are the 4 kinds of analytics? Okay, descriptive analytics, diagnostic analytics, predictive analytics, and prospective analytics. Okay, to understand, how many of you have learned about these 4 analytics? Descriptive, diagnostics, predictive, and descriptive. Yes, no? Do you know about these 4 analytics or you don't know? Yes, no. What about others? Only 2 of you them are answering. What about others? Yes. Yes, no? No. Okay, we'll try to understand the concept of it with a simple example. What is descriptive analytics? What is diagnostic? Thank you. So many of you are responding. I'm feeling happy. Okay, we always like to have an interactive session, right? So, diagnostic analytics, predictive analytics, and prospective analytics. Okay, any one of you could unmute your mic and you can respond to the question I'm going to ask. It's very, very simple question. If you go to a doctor because you have a cold and fever, what will be interaction between you and the doctor? The first part of analytics is descriptive analytics. Most of us, maybe our children, yeah, somebody has unmuted. Who's muted? Yes. And thank you, sir. What do we do when you first go to a doctor if you have cold or fever or any disease?
I will explain about the conditions what I have and what are the occurs or occurred in my body,
okay,
and how I am feeling,
okay,
and how I am able to talk, and my what is the body conditions.
What is your sufferings? Okay. What is your pain?
How many days is this disease is affected in my body?
Okay.
And what the disease is doing in my body?
Okay. Thank you, sir.
How to do?
Yeah, thank you. See, as rightly said by Dr. Parthiban, he goes to the doctor. He was more elaborate. He was trying to say how long, what is his symptoms, what it is suffering, and he goes and describes his problem to the doctor. So that is a simple example of descriptive analytics. You know the solution is with the doctor. You go and try to describe. Okay, so in data science, how many patients went to the hospital last week? Or you're going to do the first chapter is called as exploratory data analysis. You're going to try to describe that we are going to take a data set and we are going to do that. You're going to try to understand what is about the data. Then the doctor understands. So if we go to an experienced doctor or you go to a very new doctor, we always prefer to go to a
normally experienced
doctor because he has learned the data patterns, able to understand. He has learned the data patterns through his experiences. If these symptoms, it could be typhoid, it could be malaria, it could be COVID, or whatever it is, X or Y disease, the patient goes and describes to the doctor. This is a simple example of descriptive analytics. Same thing in data science. You have got a data set. From the data set, what you're going to do, you're going to do a visualization, trying to understand what is the data, what is the data trying to convey to it. So that's an example of descriptive analytics. Okay, see, now the patient describes to the doctor. Now we move on to the next thing, diagnostic analytics. What does the doctor do after hearing to your comments or your sharing with him, your sufferings or your pain? The doctor will tell you, probably this could be the disease, need not worry, but still, can you go and take up this blood test? Can you go and take up a CT? Yes. Do they tell you?
Analysis.
Yeah. Then he goes to the next level, that is called diagnostic analytics. He would have diagnosed, but he wants to confirm whether the disease is there or not. He moves to the next level called as diagnostic analytics, where it could be an X-ray or a blood test, or if he's an experienced doctor, he will be able to diagnose what disease it is. So once the diagnosis report comes, your blood report or X-ray report comes, then what does the doctor say? The report will say maybe it could be malaria, it could be typhoid or something or the other. Then the doctor does a predictive analytics. It could be this. Okay, this is the pattern of this. Then it could be dengue. If the platelets level in your diagnosis, if the platelets level is low, then the doctor would have been analyzed in the predictive analytics. It could be dengue. Then what will be the final stage the doctor does? Can one of you say? What does the doctor do after the end? After he has predicted it, he will be writing in his. He will write the tablets or the syrups onto his prescription. You remember prescription? That is called prospective analytics. Able to understand from a hindsight to an insight to a foresight. This is more important. Foresighting is more. Thank you, Sarada ma'am, for your responses, right? prescription. He writes in the prescription and he knows after how many days the patient will get. If it is typhoid, don't take food or non-veg for 21 days. Take very mild foods. Yes, they know after how many days you need to repeat a blood test or not. It is called prescriptive analytics. So whenever you take data analytics, it could be in any field. These are the 4 steps. The first thing is a descriptive analytics. Try to understand what is data all about. Second is diagnostic analytics. What are the patterns? Why it is happening? What are the features that is needed? Then you predict, you write a machine learning algorithm or deep learning algorithm, try to predict whether this patient is going to survive or patient is going to die, or this patient has got a disease or they have not got a disease. And prescriptive analytics is going the next far beyond. Nowadays, if you take blood tests, they say pre-diabetics. You foresee whether you're going to get a diabetics in the next 5 years. Able to understand? Or the next 10 years. Or if your ECG is like that, whether you are prone to get a heart disease. Everything could be done in data analytics. All right. First is descriptive analytics. You know to know what is this data. Same thing you can do it. You can map it for your exams. You write, your students write their exams, you correct it, you get their marks, you diagnose, and then you predict whether the student pass or fail. If you predict the student will fail, then you keep a special class. Yes, so anywhere you'll be able to apply this data analytics. How many, see, these are some, how many patients went to hospital last week? Okay, then the doctors will know. When you go to doctors, they always say this, right? No, the season, no, many people get cold and fever. You know, this season, many people get flu. They get dengue. This is a typhoid season, this is chickenpox season. How do they say? How many patients went to the hospital is a descriptive analytics. Then he diagnoses, why did this patient go to the hospital? Which patient will go to the hospital next week is the predictive analytics. These patients should get extra treatment to prevent hospitalization. You're able to share my screen, you're seeing my screen or not? I'll try to share.
No, ma'am.
I
No,
had.
ma'am, we can't see the slides, ma'am.
Open. Now you have closed.
Yeah, I had been sharing for a long time. Okay.
Yes.
Okay. Now you are able to see?
Yes, ma'am. Yes, ma'am. Visible.
You have not been able to see the previous slides?
Yes, ma'am.
Okay. These are the previous slides. Okay. So we have seen about descriptive analytics, diagnostic analytics, predictive analytics, and prospective analytics. Supposingly, if you're not able to see the slides, kindly post it onto the chat or you can unmute and speak. I'm okay for it. Okay. Now are you able to understand the different 4 analytics? Descriptive, diagnostics, predictive, and prospective. Yes. Give your answers on chat. Yes. No. Give it on no. Able to understand what does descriptive analytics does, what is, because without knowing these we will not be able to jump into it. Yes, if you are not doctors, see the machine learning algorithm, you have got what are the features to be selected. Okay, then selecting of features is one part of it, where it will be able to understand what are the features. That is what we say correlation all happens here. You will be able to see it once you have a hands-on session on it. Okay, descriptive analytics, what has happened? Predictive analytics, what could happen in the future or what are the previous trends and patterns? Prospective analytics is what business should do. Okay, what business should do. Now, there are different types of descriptive, predictive, and prospective. So, say for example, Lioness had hired a data scientist to help to find a prey. The fox, data scientist is the fox, for example, to make you understand. It has got what is the characteristics of fox? What is the characteristics of fox? Hello, what is the characteristics of fox or the character another? What is the characteristics of fox?
Some tactics it will do things, ma'am.
Fox
It has some tactics too. Yeah.
Cunning. Yes, it's very cunningness. Thank you.
Cunning. Yeah.
Okay. So you see, a data scientist is compared to be a fox. A lioness wants to find a prey. The fox has got a rich data, whereas you have got, like Richard sir was asking, I'm not a doctor. How will I be able to do it? At the end of the session, we'll be able to find it out. Which consists of data about the jungle, its creatures, and what are the events happening. So on the first day, the fox is presenting to the lioness with a report. Summarizing where all she found a prey in the last 6 months, where and all it could find, which helps the lioness to decide where it can go in for hunting. This is a simple example of descriptive. You have a data. As a data scientist, you need to go on with your visualization of data. That is what we are going to do. Okay. Next, the fox estimates a probability of finding prey at certain time. First, it was only 6 months. Then it is trying which time and which place it could find the prey. It is trying to predict it using machine learning techniques. Okay. So this is called as predictive analytics. First is descriptive. From the last 6 months, it is trying to present a report to the lioness where it can go and get its prey to eat. And the next is at what time and what place the prey is available. It is doing a probability using different machine learning techniques. That is predictive analytics. Also, it identifies the routes to the jungle to take the minimum effort. There and where in data analytics, predominantly we need to work on different optimization technique. Finally, on the above model, the fox will be able to find an automation. So this descriptive analytics, predictive analytics, and optimization or automation is called an analytics life cycle. Able to understand this life cycle? First you describe, then you predict, you can automate it. Okay, automizing is you give the data. How many of you have seen the climate prediction? Climate, have you seen about climates? How many of you have seen about climates? Climate in Chennai, Papingla. Do you see climates? Okay. What are the parameters you can see when you see climates in Chennai? Okay. When you see climates in Chennai, if I'm going to see, I hope my screen is seen. If not, kindly tell. Okay. What are the factors when you see a climate or a weather of a place? What and all you will see? You will see precipitation, the rain, the house of precipitation, the wind, and also can you see there is a prediction what it will be in the night. Okay. And also you can also see a monthly prediction. Can you see how data using the previous data and trends, and you are able to find how will be the weather for the next month? Can you see here? Here and where your machine learning algorithm and deep learning algorithm works. With your present data, with the data that is available, you're going in for a predictive model. Able to understand about predictive analytics? With your data patterns, and you predict it, and also when you take a satellite and try to refine your data because of your data trends. This is one such example for it. Okay, one such example for it. Now when you take machine learning and deep learning algorithms, both machine learning and deep learning algorithms, they discover patterns in data. I told you, right? You discover patterns in data. Both evolve dramatically, but they have different techniques. Both machine learning and deep learning. Okay, so machine learning or deep learning are also forms of artificial intelligence. Deep learning, see, you take artificial intelligence, the subset of artificial intelligence is machine learning, the subset of machine learning is deep learning. Able to understand? The entire thing is artificial intelligence, subset is machine learning, and the subset of machine learning is deep learning. Okay, so both you have to understand both has got both training data and testing data. We'll be going through this process hands-on one by one. Now we are trying to understand. If you're trying to take notes, kindly make a notes of it. Training data and testing data. Then you go through a model and go through an optimization process to find the weights. Okay. So what is machine learning model? First, you need to prepare the data. Second, you go in for feature engineering. Third, you go in for data modeling. And fourth, you'll be going in for performance measure. For this session, for today and tomorrow, we are going to take up a data set of a kidney disease. Okay, I will be sharing the data sets with you. So we are going to prepare the data. And one thing you need to understand before you are going to develop a machine learning algorithm, you need to convert your categorical values into numerical values. What I say categorical values in your data set, if say for example, you have got a column which is called gender, okay, which is called gender, which is male and female, then the data set will not be able to understand. You use a label encoder or you convert it to be numeric, male is 0 or female is 1. All right, for that are the things that you'll be doing into the feature engineering. First, you need to take up a data. The data will contain what are the features and what will be the target. Target is what target we have got benchmark data sets under UCI machine learning repository. Okay, UCI. Okay, UCI machine learning repository, where you have got lot of data sets. Okay, you will be taking after this session of I completing it, you will be taking one data set from this and then you'll be working on with that. Okay, so for this session we are going to focus on, can you see in my screen UCI machine learning repository? Yes, my dear participants. Yes. So can you see there are different things, classification, regression and clustering. So we are going in for classification. Okay, we are going in for classification. So I will be telling about what are the different classification, regression and clustering. Okay, can you see the different data sets on classification? As we are moving on into a disease data set, I'm going to take kidney disease. Can you see my data set now? Can you see? Yeah, this will be the data set that we are going to use. So we will be converting this categorical values into numerical values, the age, the BP of the patient. These are some metrics for kidney disease. Okay, and there this will be a target. Can you see here? CKD, chronic kidney disease. Okay, chronic, whether the patient is, can you see here non-CKD? What does CKD stands for? You can make a note of it, chronic kidney disease. Okay, chronic kidney. So I'm going to take my data set with this patterns. I'm going to find whether the particular patient with, if this component or like this, whether they're going to, these are the features. Okay, the age, the BP. I hope you're able to see my columns, whatever I'm showing. Okay, these are my features. What is my target? This column name classification is my target, which contains whether the particular patient has got disease or not. And also you can see I've got some missing values available, right? Can you see there are missing values available? All right, so you can also find if the missing values are available, what you are going to do. Okay, any doubts till now? Able to understand?
Madam, this is 41.
Yes, sir.
Where we can get this data set?
That's what I said. Yeah, you can take it from UCI machine learning repository, which contains benchmarked data set, that you see if you're going to use for classification, and I will be going into clustering and regression, just the introduction of it, not in depth. Okay, wherein I've taken the data set because these data sets are given by the doctors. Okay, say for example, I'm going to type your kidney. Okay, can you see here? I've taken this data set, chronic kidney disease data set. Okay, this is to predict. We are going to do a predictive healthcare analytics to predict the chronic kidney disease, and it can be collected from the hospitals nearby for 2 months. And see, it has got 400 rows and 25 columns. Yeah, there are missing values. Some hospital has donated. Can you see the date it is donated? And we are going to do for classification, and we are going to work on for classification. That is what I've taken that. And also see clearly, you can see who's the creator. They have taken it from Soundrapandian, Dr. Soundrapandian from Apollo Hospital, Madurai. Okay, and who's the creator? Gerlin. She's a research scholar and who has guided that. Okay, and can you see the data set information, the age, the blood pressure, Okay, they've taken the specific gravity, albumin, sugar, red blood cells, first cell clumps, bacteria, blood sugar, blood glucose, random blood urea, serum, creatinine. Creatine is a very important component, right? Sodium, potassium, hemoglobin, packed cell volume, white blood cells. Okay, hypertension, diabetes, whether they've got a diabetes mellitus or not, the coronary artery disease, appetite, fetal, and anemia. And they have used 24 plus 1, 11 numerics and 14 nominals. Okay, what are the values, attributes, information, ages are a number, blood pressure, every information you get. Albumin nominal, the sugar level from 0 to 5. Yes. And then which is CKD or not CKD. If it is yes or no, anemia or not. Pedal edema, yes or no. Appetite good or poor. Yes or no. Okay, some of them are categorical values. Categorical values are string values. Some of them are numerical values. Blood urea and all, the serum, these are all ureas are all numerical values. And also here, if you click, you can go into the data folder. Can you see here? I've downloaded it and I've made it as a CSV file. CSV, it stands for comma separated values. Okay, comma separated values. And then also you will be getting the data set description. When you click on data set description, you've got the entire data set description here. Okay. Is it okay, sir? Okay. So now moving on to, so we have prepared the data. We have prepared the data. First step, we have taken the data. We need to load in onto the data. Then we go on for feature engineering. Then we'll be going into a machine learning algorithm. Then the fourth step will be moving into a performance metrics. These are the steps that we will be doing it step by step for these 3 days. First, we'll complete with the text data that I've showed you. And eventually, we'll be moving into a image data set and how are you going to find. Okay, so now listen carefully. This is the very, very, very important thing. Okay, when you want to work with the disease data sets, you take a disease. What is the disease data set that we are going to take? Can one of you unmute and speak? I told you what data set we are going to take.
Kidney data set.
Thank you, thank you. Pangajavarnam, ma'am. If I'm spelling Panjavarnam, I'm sorry, Panjavarnam, ma'am. Okay, okay, okay. So you're going to take a disease data set. What are the things we are going to do? Feature engineering. Once feature engineering is moved on, the next step is most important. It is called as the data modeling, or you can also name it as machine learning modeling. You're going to have a disease data set. You're going to split into training and testing. I'll be describing each step once you will be doing it. Okay, in the training, I'm here for this diagram. They have given 3 algorithms. You need not write algorithms. Python package itself is giving a pool of algorithms wherein you can take it up and find it out. I will be showing one data set. I want all the participants to be working on to another data set. Okay, you can take it from machine learning repository, or I can also share a data set with you. You can run it and then show it to me. All right, I will be creating a Google Classroom wherein you can share all your repositories. It will be easy for us to see. Okay, naive-based algorithm, random forest algorithm, decision tree. You take it. See, every time as a research scholar, when you are going to develop one work, okay, for one publication or one contribution of your research, at least take 3 data sets and try to work with minimum 3 algorithms. To complete your entire research, try to have at least 3 to 5 research contribution. In one research contribution, don't take one data set, run it out and get a result. No, at least take 3 different data sets. All right, and few algorithms, maybe 5 to 7 algorithms. You know, I have interns now, and in my company, they started from January. Now it is March. The students have completed 23 algorithms. All right, and they are doing the performance analytics, right? And then out of which you're going to find which is the best or worst or what is the medium kind. Then you'll be, this are all done in the training set. Then for the testing set, you'll be giving our data, only the feature, and it is going to predict whether the particular patient is going to have a disease or not. Okay, and then we go on for the performance metrics. There are several performance metrics. I'll try to teach what is the best performance metrics that I could teach you. All right, that is that we could be able to taught. Okay, so when you come into classification, I told we are going to focus on classification. There are three basic things. One is classification, clustering, and regression. I'll tell you when to use classification, when to use clustering, and when to use regression. But for this workshop, for this program, we are going to focus only on classification and developing a predictive model using classification methodology. It is going to use predict a discrete class or label, okay, whether the particular patient is going to have a disease or not. It could be, the output could be 2 if it is yes or no. Say for example, some diseases have got stages. If you take cancer, right, no cancer is 0, stage 1 cancer, stage 2 cancer, stage 3 cancer, stage 4 cancer. So those things comes under multi-level, okay, multi-level classification and multi-label classification. Multi-level, okay, multi-classification. If for this work, first time what we are going, because most of you said you have not worked on it, we are going to work only with binary classification. You are going to find with these features whether the particular person has got whether the particular person has got a disease or not. Then after you develop an algorithm, after you develop, you feed a new data set, a new patient comes, and when you can develop to be a machine, a web application or mobile application, just feed in the values and click on predict, and you're going to say with the machine learning algorithm that is trained, your application will say whether this patient has got a disease or not. This is where it can be applied in the hospitals. Okay, when a scan report is given, when it is fed into your algorithm, when it is fed into your application, these values are given because your algorithm is trained in such a way to predict for this particular disease. Able to understand? So the classification basically involves 2 inputs. One is the classes that belongs to the classification model, and that is a labeled classification. Labeled is you have a target. Whenever you have got a target of yes and y, or yes or no, the disease is present or absent, these are called, these comes under supervised learning. When you don't have a target, it comes under unsupervised learning. Okay, unsupervised learning. So labeled data, what is the labeled data here? Can you see? This is my labeled data, CKD. What does CKD stands for? Chronic kidney disease, or no means no chronic kidney disease. Okay, and as said, we have got 400 columns. See, 0 to 399 columns, and you have got both categorical and numerical values and also missing values. That is what I've chosen this data set. Okay, and when this, listen to this very, very carefully. Listen to this very, very carefully. So when you are going to start with your algorithm, okay, how I told you, right, how will you find whether you're going to use a classification or you're going to use a regression or clustering? Okay, and when you get a data set, the data set has got more than 50, then you go on for the machine learning algorithm. Can one of you say how many rows that we have, that the data set that we have chosen has taken? Can you put the answers on chat? Or also you can unmute and speak. Yes. How many rows are there in the data set that I've showed to you now? Answers on chat or unmute, but be quick.
Ma'am, 400.
400, exactly said. Thank you, Manaka ma'am. Exactly said. We have got 400. So when you come to this, so starting, it has got more than 400 means more than 50 samples. If you have got, if your data set has got less than 50 samples, you need not develop your machine learning algorithm. You have to go and get more data. Once you have got more than, no, now we have got 500. So it is yes. We come here, and then the next set, can you see? You're going to predict a category, yes or no? I want you to give me an answer, yes or no? Syed, sir or ma'am, I don't know, professor, what is that you give how? I'm not able to understand. You can also make your question more clear. It has got 400 samples. This sample, okay, I showed you, right? This sample is going to predict a category or not? Yes or no? Can you tell me? Yes, there is a classification. Disease, yes or not. You're going to go on for a prediction of kidney disease, yes or not. Right? Yes. How 400? See, this is the data set. I'll be sharing it with you. Okay, can you see the data set has got from row number 0 and it goes up to row number 400, that is 0 to 399. And this data set I've taken it from UCI machine learning repository. Okay, here also you can also download it from the data folder. Okay, 400 rows and 25 columns. It is taken from the hospitals, and it is donated in 2015. Okay, and not only this data set, say for example, if I'm going to check for a heart disease data set in my UCI learning machine learning repository. Okay, can you see here? There is a data set for heart disease. You can take an heart disease, and after we complete this work, I wish you to take a heart disease data set and keep working on with that. Even that, these are benchmarked. See, it is given in 1988. 1988, this data has been given, right? It has got 4 databases from Cleveland, from Hungary, from Switzerland, and VA Long Beach. See who are the contributors from Hungarian Institute, from Switzerland, Zurich and Basel, and VA Medical Center, and they've got 76 attributes. Can you find? This is your target, whether the particular patient has got heart disease or not. Okay. Yes. Likewise, you can keep on working. So here, when you come into a thing, yes, the person has got, there is a predicting a category, yes or no? Yes, it is predicting a category. Yes, whether the particular person has got a CKD or not. Okay, then coming into it, whether you have a labeled data or not labeled data, whether you have a category for, we have got a target for this data set. Have you got a target for this data set? What is my target? This is my target. The last column is my target. With these features, I'm going to find my target. These are my data, and this is my target. What is my target? CKD is my target. Whether the particular patient has got a kidney disease or not. Able to understand? So it's a labeled data. If I don't have a target, if I've got only features, then we cannot go for supervised learning. We need to go on for unsupervised learning. Here I've got a labeled data. For every row I've got a label, whether the particular patient is there or not, has got a disease or not, then it is a labeled data. Do you have a labeled data? Yes. If not, you go on for clustering, you don't go for classification. Since my answer is yes for this, and it is less than 1000K, yes. Sorry, 100K samples. If it is more, then you go for SDD and kernel optimization. Okay. Yes, I go for linear SVC algorithm. If it's not working, okay, and then we go on for SC. If it is working, it's text data. I can go for neighbor-based, K-neighbor classifier. We are going to use these 3 algorithms: linear SVC, K-neighbor, and neighbor-based. If it is not working, then we go on for SVC with ensembler classifiers. If I don't have a target, then you go for clustering. You just cluster. If you see people going into the malls, we go into malls, right? How many of you have visited malls? What are the categories of people that you think that they go for malls? Like EA or different places have got different malls. What could be the category of people when we go to malls? Can one of you unmute and speak? Hello? Hello? How many have visited malls? Yes, no? Hello? We go to malls, right? Everybody in the malls, they go to buy things, or some of them, yeah, yes, Syed, Nehiri Syed ma'am, okay. Whether people go only to buy or they go for food malls, what are the different categories of people that you think they go for malls? Some just they go and spend some time and come, right? Some of them they go to buy things. Some of them they go with some objective. Some of them they go just see it out and come. And you don't have a target. For a disease, you have a target, whether it is yes or no. When you go in for a malls, when people go for one example, I'm taking, we go for malls, we don't have a target, right? Then you go on for clustering, which means you don't have a labeled data. Then you go for clustering, number of categories, no, yes, and it is less, then you go for mini batch. If it is no, K means, and if the data sets are less, then you go for mean shift. If it is less than that, then you have to go on for another work. You have to fetch for more data. If you have continuous variables, if you have got continuous variables, then you go on for regression. Then you go on for regressions. Regressions means continuously changed variables. Okay, you want to predict a category? No. Okay, you see the stock exchange. Yes, stock. I don't know anybody has been involved in stock exchange. So BSC, it keeps changing. It's a continuous, a drug response is a continuous changing variables. You don't have a predicting a quantity. If you're predicting a quantity, yes, how will the stock exchange? And less than, then few features should be made important. If it is no, then you go for SDD classifier. So this is the structure that is given to what algorithm that you want to use, that you would like to use. Okay, you predict a category, yes, no. Then if a dimensionality is, if your data set has got a huge dimensionality, then you go for dimensional reduction. These things we will not be seeing now, but you need to understand what it does. Okay, able to understand till now what we have seen? Okay, category, a classification is to identify which category an object belongs to. For spam detection in email, you can use that algorithm. For image recognition, like algorithms like SVM, K-nearest neighbors, and random forest, there are plentiful algorithms available. Regression is for continuous valued attributes, like I told you, like drug responses, stock prices. Like for that algorithm, we go in for SVR, ridge regression, and lasso. Clustering, I told you, don't have a labeled data. You don't have a target, wherein you automatically grouping. I told about customer segmentation, coming to a shop, going to a mall. Okay, and there we use different clustering, like spectral clustering, mean shifter, k-means. So when you go for dimensionality reduction, reducing the number of random variables to consider, like how do you visualize, how do you increase efficiency, what are the features. Say for example, if you've got a data set of 100 columns, then you need to incorporate feature engineering algorithms to optimization algorithm to extract what are the necessary features that has got a strong correlation towards your target, and then you'll be able to do it. Okay, and model selection, and where you have to improve, like this comes under hyperparameter tuning. After you get an accuracy and after algorithm, we go in for cross validation using grid CV or so many methodologies. This is to improvise your models, therein where you can, as research scholars, you can have your own contribution. Okay, these are some examples of classification algorithm: generalized linear model, super vector machines, discrimination analysis, okay, nearest neighbors, neighbor-based decision tree, and different ensembles method. So when you come, now we are going to focus on into a classification. When you come into classification, it's divided into categories. Now what we're going to see in today's and tomorrow and their tomorrow's workshop is that, okay, which category, binary classification. We're going to take kidney data set and find whether the particular person has got a disease or not, multi-class or multi-label. Okay, different, you have got not only one, like 0, 1, 2, 3, multi-class. Okay, multi-labels, the label itself is multi-labels, not only a single target, multi. So you'll be going in depth with multi-class or multi-label classification. So to start with, to know about data analytics or predictive healthcare, for very simple start, we are taking this data set. Okay, what is binary classification? Here you're going to classify the items because belong to two groups. What is the data set that we are going to take? Kidney disease, present or not present. Okay, like predicting whether, if you take image analytics, whether from an image, from an MRI image, you're going to find whether the particular patient has got a disease or not. Okay, or picture is cat or a dog, some prediction. Okay, email is spam or not. Multi-class, one or the three or more. So contradicting to the binary class, I told you 0, 1, 2, 3. Some typical class could be sports or entertainment or political. Okay, we have a sentimental analysis on Twitter or any data sets, okay? Whether it's positive, negative, or neutral, how do you segment for customers for marketing purpose? Okay, multi-label, this can be easily confused with multi-class. Okay, multi-class is a single label problem, but the categories are different. But in multi-label, the target itself is 2 or more. The labeling is one we have seen. The label itself will be 2 or 3 columns. That is called as multi-label classification. Okay, multi-label classification. So what are the few steps that we need to do in for machine learning algorithm? First, you have to take a benchmark data set. We have chosen what is a benchmark data set that we are going to use. All right, and then you go on for exploratory data analysis. That is what we'll be doing. We'll be doing about the visualization of data. Then we'll be using data curation. In data curation process, predominantly what we will be using, right? You cannot use categorical values. When I say categorical values, you cannot use like what do I say, like values like gender, male, female, no, yes, no. You have to convert it using a label encoder. Okay, and then you go on for feature engineering. What are the necessary, if your features are more, then we need to extract it, and we're going to find whether you're going to have missing numbers or not. All right, and then we develop a machine learning algorithm and performance evaluation. So these are the 6 steps we are going to do on our hands-on for today and tomorrow. All right, we have taken, I will share the data set with you now. Okay, then exploratory data analysis, data curation, feature engineering, development of machine learning algorithms. Yes, can we start? Okay, so a data set is a starting point of your journey. So we have shown you a data set. This is called M cross N. M denotes the number of columns, which are the features, and N denotes the number of rows, that are the samples. So what are the features for us? You know, what are the features? I showed you, right? What are the features? These are the features. This column names are the features. Can you see? These column names are the features. Okay, so these are the features. So these features, and this is my target. Classification is my target. So when you see here, data set consists of so many columns. Those are the features. Everything is a number of rows. How many rows we have in this data set? How many rows we have in this data set? Hello? How many rows we have in this data set? Anyone answer? Yeah, I'm seeing an answers on chat. 400. Thank you. Thank you. 400 rows are there. All right, 400 samples. So now you know how will you write this data set into M cross N matrix. Can I have the answers on chat? How many columns we have? I will show you how many columns we have. I showed it onto your. How many columns we have? Not this data set. This is for the heart disease. Yes, 25 columns, right? So how will you write? These are my, what is M, what is N? I want you all to write on the chat M cross N. M is total number of features. N is total number of rows or instance. M is the column and N is the row. How many rows and how many columns? I've shared it. I want the answers on chat. I want everybody to. What is M? How many features we have? M is equal to how many features we have? How many attributes we have? 25. And then what is N? Number of row instance? 400. So how will you write? 24 cross 400. 25 cross row. So M is total number of features. N is total number of rows. Right, correct answer. Yes, Arlene ma'am, your answers are right. And yeah, Syed ma'am, your answers are right. Yes, Deepa ma'am, your answers are right. And yeah, Suruchi. So I'm sorry if I'm spelling your name wrong. Okay. Okay. Panjavarnam ma'am. I think I'm spelling it right. Okay. All right. So you're able to understand. Okay, I'm happy you are all responding. Out of 60, I can get 10 or 15 responses. I don't know about others. All right, but I want everybody to answer it. Okay. So are able to understand. See, understanding a data set is more important. Without understanding, we cannot be able to jump. So M cross N. Okay, like 10 of you have responded. I don't know about others. I wish everybody you responded. Okay, so here you've got X. X are similar terms. Okay, these are the features. Okay, each feature is independent. Age is independent from your gender. Okay, 25 samples and 400 features. Thank you. Why? Okay, now these columns, right? Now you are able to know about M and N. Okay, what is M? M is total number of columns, which is 25. N is total number of rows, 400. Yes, thank you, Manaka ma'am, you are right. Now, these M, the total M, I am going to split into X and Y. What is X? X are the features and Y is my target. Okay, X are my features. X is several similar terms such as the features, independent variables or input, and Y is my target, which is my dependent variable. X's are independent variable and Y is my dependent variable, and that is my output variable. Okay, coming into our data set. What will be my X? These are my X. Can you see? These are my X. Okay, the age, the BP, okay. These are my X. And my classification is my target. That's my output variable. These are independent variable, like age. For that age, what is the BP of that person? I don't want who is the person, but I want only the variables because I'm going to develop a model after which I'll be giving my own data input and from which it is going to find it out. Okay, can you see here? These are my X and my target is, what is my target variable? Classification is my target variable. So how many X I will have? 1. Idea I will be able to delete it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Can you see? These 24 are my X, and what is my Y? Y is my classification. That is my target variable. That is my target variable. Able to understand? X is my all my features and Y is my target. Okay. X is my feature. How many features I have here? 24 features, and Y is my target. So 24 features and Y is my target. What is my target? My prediction model is to find whether my data set has got that this particular person is going to have a disease or not. Able to understand till now? I'm going to M columns, I'm going to split into X and Y. X contains my features. These are independent variable and input variable. Y contains my class label, dependent variable. So entire column, these are my set of features. This is my target. Okay, the samples are 400. Totally X plus Y will be my M. X plus Y will be my M. Yes. See, when you're going to use machine learning technique, if you're going to develop a predictive model based on input and output data, if the data are discrete, then we go in for classification. If the data are continuous, we go on for regression. When you don't have a target, where you don't have a labeled data, okay, then you go for unsupervised learning. You just group it and determine what kind of data sets it is there. Then you go on for clustering technique. Therein you go on for clustering technique. Okay. So you're able to understand the theory of classification, clustering, and regression, and how the data set works. Yes? Yes, no, no, yes. Answers on chat, please. "61 of you are present. Yeah. Deepa ma'am has given us. Ruchi ma'am has given us. Panchavarna ma'am, Menaga ma'am, Arlen ma'am. Understood. Thank you, Deepa. Okay. So I have a raw data set I given to a supervised learning. I will be splitting into data, training and desired output. Then I have my algorithm. It goes into the processing and the model is trained and you'll be getting an output. Okay. Unsupervised, I don't have a target. I'm going to feed all my values like apples, bananas, and mangoes. It doesn't have any output, no training data set. It is going to interpret it and cluster it to be, you have got set of apples, bananas, and mangoes from the feature it has been extracted. From the feature it has been extracted. All right. So when you take the difference, between supervised learning and unsupervised learning, input data is labeled. Here input data is not labeled. User training data set, it's just input data. Here it's used for prediction. Unsupervised data is learning is used for analysis. Here it comes classification, regression, and clustering, density estimation, and dimensionality detection comes under unsupervised learning. Okay, till now we have seen what is supervised learning, unsupervised. You should be very clear which algorithm where you need to use it. That's more important. All right. We are going for prediction, you have to go on for supervised learning. If you're going for analysis, say for example, in a class with a set of marks, you can be analyzing into students who learn well, the above average students, and below average students. You don't have a target, right? So it is for just analysis. You go on for unsupervised learning, you don't have an output. But if you want to find where predict with same data set, the student is going to pass or fail, you have a label data, yes or no, P or F, then you go on for supervised learning. Regression, the value should be continuously changing variables. Able to understand till now? Okay. First, we are going on for a exploratory data analysis. Okay. I will be sharing it and I will be posting everything onto a Google Classroom. I will also allow you to join to that. Okay. I will share that link and I'll post my data set there. Okay, so that you will have your content over there. So I've just created a classroom so that as and when you prepare your work also, you'll be able to post it on. Okay, I'm giving the link here. You can join to the Google Classroom. And I will be, I'll post it. I'll post the data set here. Kidney data set. You can just click the link and join. And I posted it on. You can click it and then upload it to your Google Drive. Okay, upload it to your Google Drive. Just click the link, you'll be able to join. Yeah, so many of you have joined. You can also see whether your name is present. You can go to the streams and just click it and upload it to your Google Drive. You need not download also. You can just upload it to your Google Drive. Click it on and upload it to your Google Drive. Okay. If some of you are finding it difficult, I will also share it. But I wish people to join into this so that it will be easy for us to work on. Maybe for the first time, I will share the data set onto the Zoom itself. Yeah, I hope you should have got the kidney data. If you have got the kidney data set, just upload it to your Google Drive. Upload it to your Google Drive. We are going in for your exploratory data analysis. Okay, where you're going to understand what is this data all about and how it could be done. Okay, we are going to understand about this data set. Okay, eyeballing, or sometimes you also say like eyeballing the data set. to understand. First is descriptive. In ADA, there are three things that is more important. Okay, please give class code. I've just given the link, ma'am. You just click the link, and the last three thing is the class code. Nowadays, Google Classroom, they've updated. Just click the link and you can join. 5J, you want the code? Yeah, I can give you the code, no problem. This is the code. But more than going to the code, just click the link. It will be easy for you to join. I've given the link. Just click the link and it will be easy for you to join soon. I can show you who and all have joined. Okay. Only 6 of you have joined, others. Out of 60, only 6. Okay. Okay. So here what we are going to do, what are the things we are going to do in EDA? Today we are going to do exploratory data analysis. We are going to find the mean, median, mode, standard deviation, descriptive analytics, data visualization. We are going to see about heat maps, how far the features are correlated with my target, the different box plots, okay, to find visual different group difference, scatter plots, the correlation between the features, okay, PCAs, and also pivoting data, grouping data, filtering data. Okay, you also join. Thank you, Deepa ma'am. Okay. So visualization, if I'm going to give you 2 lakhs of data, you will not be able to do anything. Rather, if you're going to see it through visualization, it will be easy for you to different kinds of, this is called an violent plot. Okay, the Boxen plot, the scatter plots, okay, the box plot, the heat maps. Okay, heat maps. So for that, the first package that you're going to learn is called as Pandas, which stands for Python Data Analysis Library. It's a very, very fast and powerful, flexible tool that uses the open source data, right? And manipulation of it, okay? And once the data set is loaded, what is my data set here? I've given a CSV. I want you all to upload it to your Google Drive. Whatever Gmail that you're using, upload that to your Google Drive. Upload that to your Google Drive. So you're going to load the data set into Pandas. Okay. Once, listen carefully, once I take my CSV and load it into my Pandas, okay, the data type of the CSV converts to a part called as data frame. Okay, data frame. I repeat it. Once I take my CSV or an Excel file or an Hadoop file or an SAS, whatever could, or a statistical file, I'm going to take the data set. Once I'm going to take the data set and load it into my Pandas, listen very carefully. The data type of my data set, once it is into the Pandas, the data type is called as data frame. The data type is called as data frame. When you take Pandas, it's very popular and very easy to learn, and you will be experiencing it. You can take it from a CSV, from an Excel file, from a HTML page, from a text file, whatever it is. Okay, it allows you to apply the same framework for all these sources. You're going to clean the data, visualize it, and optimize it using built-in functionalities. Okay, what you can do with Pandas? You can install Pandas. It's already installed. You can manipulate the data, find the features, ranking. If there is any missing values, then your machine learning algorithm will not work. You have got visualization for missing values. Then for filtering your data, okay, concatenating 2 data frames. I have even worked with 20 lakhs of data and it works perfectly fine. Okay, crores of data also works fine. Filtering, data set, group by function, describing, and different panels. Okay, now open up a new page and give on to the chat. Okay, we'll show it on another thing so that you will understand. Even directly from this also you can load it, but now I'm not showing that method. If there is time. Okay. Just give colab.research.google.com. Don't use this, since it's hands-on, don't use mobiles. How many of you are using mobiles or PC? If you're using mobile, put M. If you're using PC or laptop, type P. And click on New Notebook. Okay, click on New Notebook. colab.research.google.com. If you are using mobile, you cannot do it. Because it's totally an hands-on session. colab.research.google.com. Okay. Nobody is using systems. Then you can name it as kidney prediction or whatever it is that you want to predict. And the file name is IPYNB, which stands for Interactive Python Notebook. Okay, then you have to give pandas, import pandas as PD. PD is a user defined variable, you can also change, but furthermore, if you want to use pandas package, you need to give it as PD. Import pandas as PD. Click colab.research.google.com, then click on New Notebook, rename it. I'm giving it as kidney prediction. Then give import pandas as PD. How many of you have completed it? Do not use mobile. Or can we have the hands-on session in the afternoon? I think we have got, 16 minutes more. Those have done, afternoon you need it. Okay. Yeah, but still I will be trying to do that. Very simple things, you try to listen to it and eventually try to do it in the afternoon also before we start off with the session. Okay, since see, I have my data set here. Can you see kidney underscore data disease.csv? Okay, this is the mail ID I'm using, and I'm using my Colab also using the same mail ID where you have loaded your Google Drive. Just loading part alone I will teach, and then you'll be able to do it. Okay. Okay. Can you see here? Can you see files? I'm going to click on files, and then step 1 is clicking on the file. Step 2, the folder onto the top. You'll get like this, mounting Google Drive, because my data set is on Google Drive. I need to mount it, and this Colab will be also stored in your Google Drive. So no worries, wherever you go, you'll be able to work it on. It's not like anything that is local. Can you see? Once it is loaded, I get drive like this. Click on this drive and then go to my drive, and it will load whatever the files that I have. Here I need to find it out where I have. Don't see in my thing, I've got so many things. Yeah, can you see there is something called kidney underscore disease.csv? Click the three dots and select copy path and select copy path. I have imported. What is my data type? It is CSV. I'm going to have a data frame. Maybe df is equal to pd dot read underscore CSV, and then within a quotes, I'm going to, within a single quotes, I'm going to load it. So once it is a CSV file, I'm loading into PD is my pandas. Since the data type is CSV, I'm going to give read underscore CSV. If I'm going to give df dot head of, I'll be able to see the first few lines. The first 5 lines. See, I'm able to upload my data set. I can upload my data set. Can you see? DF. And furthermore, DF dot, they want to find the type. I told it's data frame, right? Type of DF. See, pandas. Actually, the data type was CSV, comma separated values. And then I'm going to type of DF. DF dot shape. You'll be getting how many rows and columns. 26, I'll be dropping this ID. I'll be dropping the ID. All right. Those are trying now. I will repeat it. First, open up colab.research.google.com. All right. And then rename it. Click on new notebook, rename it. On the first cell, click import pandas as PD and then give shift enter to run it, or shift, or you can also click this one to run. Then since my data set is into the Google Drive, I'm going to click on the folder, then onto your top right, then click on this drive, it will get mounted. Then click on drive, step 3, find out where your data set, where you have loaded onto your, where have you loaded onto your Google Drive. Then click on the 3 dots on top right, on the right, then copy path, then you open a new cell and give df is equal to pd dot read underscore CSV and then run it off. How many of you have got till this? Yes. If you've got till this, but since you are not able to see some of the columns, I can do that. PD dot set underscore options. Okay. Sorry, set underscore option. Display underscore max underscore rows comma 999 PD dot set. If I want to know more number of rows and columns, you can, because you are seeing some dots over there, right? Display underscore max underscore columns comma 999. Now if I'm going to give df dot head off, you'll be able to see all the columns. Can you see? Before which you were not able to see all the columns. You were able to see like dots here. Can you see? After BA, we were able to see only PCV. These columns were hidden because default only few columns. So I'm setting my changes to maximum 999 rows and 999 columns. Okay, I want to know how much you have completed. Okay, from which you want to share, ma'am? Is my voice breaking for others? Hello? Is my voice breaking for others? You're able to hear me? First, open colab.research.google.com. Then create a new notebook. Create a new notebook. All right. And then rename it. Open a new cell, import pandas as PD, then click this to run or give shift enter. Then click on the folder onto your top left. Click on drive. Drive gets mounted. And then go and search where you have your data set. And click on the 3 dots. Then copy path. I told right the day pandas. I'm loading my data set. It's of CSV. pd.read_CSV. What is your content? Then df. Then df.head of. You'll be getting first few rows since the columns were hidden. 5 rows. Head will tell me the 5 rows if I give the tail. The type of df is a data frame. df.shape 400 and extra one ideas it has taken. We will be dropping it down. Sorry, because some columns are not able to see. I am dropping it. I am making the display of maximum rows as 999, maximum columns. df.head, I'll be able to see all the rows and columns. Yes, please. How many of you have loaded? If anybody has got difficulties, any errors or something you got, you can just post it onto the classroom streams, your screenshots, so that it will be easy for me to find it out. 17 of you have joined. What about others? Like 58 people are here. Because all the content not audible. Am I not audible? Hello? Please do tell me. Yeah. If you are getting some errors, post it on. I know everybody, you know about Google Classroom. Post your pictures here of any error or what. So it will be easy for us to find it out. How many of you have loaded the data set into your Colab? Or any errors you're getting, you can just take a video on your mobile and then post it onto the Google Classroom. Yes, please. Hello. I don't know why. First, import pandas. Go to Colab. colab.research.google.com. All right. And then first, only the first package we have taken, pandas, and mounted onto it. Click the drive. And for some, if you are doing it for the first time, it'll ask you to connect to Google Drive. Click on connect to Google Drive. Then from the drop down menu, search for give all, you'll get a ID. Okay, you copy that ID and paste it onto the cell. Then it gets automatically mounted. It happens for a few. It happens for a few. Okay. If you have mounted, and then if you have got df.head off, kindly let me know. Yes, it's an hands-on session. All right, I want your complete cooperation. This I've done so many online sessions on image analytics, on LATEX 2. Do you know about LATEX 2, a tool that is used for developing, writing research journals? All right. Only 17 of you have joined out of 61. Kindly join, because all the resources I'll be posting into this. Supposing if you've joined late, again I'm posting the new classroom invitation. Just click it on and you can come in. I've shared my data set here. How many of you have got loaded into it? Is anybody, one of you have unmuted? Is Panjavarnam ma'am, any doubts? The afternoon session, when we start by 1 o'clock, kindly keep your systems ready. Kindly do not join using mobile. All right, and then open your Colab and upload your data set that I've given in the Google Classroom. What is the error you're getting? Okay. Okay, I'll check it out. Yeah, mount, run this cell. Click this to mount, sir. Click it to mount, and then you'll get an email, your mail drop down. Then you'll get a code. Copy that code and paste it. Okay, so in today's session, we started with the introduction of data analytics. Okay, we have started with the introduction of data analytics. What is data analytics? What are the 4 types of data analytics? Predictive, diagnostic, descriptive, diagnostics, predictive, and prospective. And then we moved on to what is classification, when do you want to use classification, regression, and clustering, and what are the steps to develop a machine learning model. Okay, and understand, mostly we worked on how to understand what is predictive, descriptive, diagnostics, predictive, and prospective analytics, and what are the theory part of developing your machine learning algorithm. And then we started opening a Colab, and I've shared a data set with you on kidney disease, and you have loaded onto it. All right, and this is what we have seen. Afternoon session will be having a hands-on. I want everybody to use your systems, your PC or laptops. Then only we'll be working with ED8 for today's afternoon session. All right. Okay, over to the organizers.
Thank you, ma'am. Thank you, ma'am, for this wonderful session. Now, I request the participants to clarify the query, if any.
Welcome, Adeline, ma'am. What about others? But mandatorily, I want everybody to use your PCs or laptops for the afternoon session. And also join in through the Google Classroom, wherein only 17 have joined. And if you organizers have got any WhatsApp group, or you can also post the link onto that, what I posted onto the chat.
Okay, ma'am. Sure, ma'am.
Okay.
So, I hope this session is clear. I now request the participants to take a break and join again at 1 p.m. after the lunch for the next session. Thank you all. And the feedback link is shared in the chat box. Kindly complete the feedback procedure. Thank you all.
Welcome. Welcome all. See you at 1.